In this video, we're going to be going over a useful rule in probability called the combinations rule. But to motivate that, we're going to start with a simple example. And for our example, we're going to have a jug that's going to have 3 balls in it: a red ball, a blue ball, and a green ball. And we're going to try to figure out what the probability of drawing a blue and a green ball in 2 draws. So we have 3 possible balls in the jug, and we're going to take out 2 of them. And what is the probability that those 2 are the blue and the green ball? To calculate that probability, we need to know what our total sample space is for that draw, and we need to know what our successful outcomes are, what our specific event is that we care about. So to calculate the total number of possible outcomes, our sample space, we're going to just write down all the different sample points. So we have red and blue, we have red and green, and we have blue and green. And since we only have 3 possibilities and we are drawing 2 balls out, those are all 3 of the possible outcomes for our sample space. So then to calculate the probability of drawing a blue and a green, we just need to know how many ways are there to draw the blue and the green. We just have the one way. And we know that there are 3 total ways to draw out balls from this jug. So we're just going to say 1 divided by 3 for the one way out of 3 is equal to 33.3%. So we're going to say that the probability of drawing a blue and a green ball out of this jug is 33%. So this is a pretty basic example, but you could see how this might be a lot more complicated if we're, say, have a jug with 20 different balls in there, and we're trying to calculate the probability of drawing a specific set of 7 of them. And that gets a lot more complicated because we have to list out all of the 7 ball combinations that we could possibly draw out of those 20, and that becomes a much more trying task to do. It's going to be a long, drawn-out process, and it's going to be very challenging to make sure we don't actually make a mistake to do that. We have a tool called the combinations rule, which is going to give us that number so that we don't have to actually write down all those different possibilities. And the way that we're going to calculate that rule is, first, we're going to say that the combinations rule is we're going to write that out as cap n over little n inside of this large parenthesis kind of piece. And this isn't a fraction. We're actually saying what is the total number of ways that we can draw little n balls or little n objects or whatever out of cap n items. So basically trying to say I have cap n items, so maybe I have 20 items, and I want to know the total number of ways that I can draw, say, little n items or 7 items out of that. And the formula for that is we have our cap n over little n is equal to, we have n cap n factorial over little n factorial times cap n minus little n factorial. So to use this formula, we're going to need to know what a factorial is. So we're going to say that k factorial is equal to k times k minus 1 times k minus 2 times k minus 3, and all the way down until we get times 2 and times 1. So this factorial formula is basically saying for all the integers less than our value, we're just going to keep multiplying all those values together until we get a number. So for example, if we wanted to calculate 4 factorial, we would have 4 times 3 times 2 times 1. And if we do that, we get 4 times 3 is 12, times 2 is 24, times 1 is just that same 24. So we have 4 factorial is equal to 24. So let's walk through just a simple example of how we can use this. Let's say that we have a jug that has 7 balls in it, and we're trying to draw out 4 of them. So how many ways can we draw those 4 balls out of the total of 7 balls that we have in our jug? So to do that, we're going to say that our cap n is 7. So we have 7 total possible options that we can draw out of that jug, and we're looking at all the combinations of 4 balls. So we have 7 balls total. How many different ways can we draw 4 out? So to calculate that, we're just going to use our combinations formula. So we're going to go 7, choose 4. And we know that that formula is equal to, we have 7 factorial divided by our 4 factorial times 7 minus 4 factorial. So if we break that out a little bit more, we have 7 factorial over 4 factorial times 7 minus 4 is 3 factorial. Now we could actually go through and just do all these different multiplications. So we could do 7 times 6 times 5 all the way down to 1 for the top. We do the same for the bottom, but we actually have kind of a cheating way that we can do this. And the way that we're going to break that out is we're just going to write some of these values up here. So instead of writing 7 factorial, we're going to write 7 times 6 times 5 times 4 factorial divided by our 4 factorial times our 3 factorial. And now we can just do a standard math trick where we just cancel out the top and the bottom. So we're going to cancel out our 4 factorial and our 4 factorial. We're just going to have 7 times 6 times 5 divided by 3 factorial. So if we keep doing that, we get 7 times 6 times 5 all over 3 factorial, which would just be 3 times 2 times 1, which would be 6. So we get 7 times 6 times 5 over 6. And we can do a cancellation again, so we can cancel out 6 and 6. So we just now get 7 times 5 as our total formula, which is equal to 35. That's just a simple example of how we can use the combinations formula to calculate those different possible outcomes. And we can use this for much larger numbers to kind of make that calculation significantly easier than actually writing out all the possibilities.